elements we have here? Elements are oxygen, sulfur, selenium, tellurium, polonium. And one more is there. It's called livermorium. I don't know whether in your book it is mentioned or not. It is livermorium. Out of that, polonium and livermorium are radioactive. Okay, these are polonium and livermorium are radioactive. Second, general electronic configuration is NS2 NP4. Acha, by the by, all of you here, including Somnath also. See, as because the chapter is very big, and I somehow did not learn the art of teaching is that. Huh? Please remember, note. Oxygen, sulfur, selenium, and tellurium are called as chalcogen. Please remember for your entrance exam. Why? Chalcogen means which can form element. These these four of them are associated with most of the minerals, and from those minerals only we get the elements. So please remember. Now we'll go for physical properties. So it will be just like that of the group 17, sorry, 15. Physical properties. So this I will not take in detail. So first one is what? Atomic and ionic. So you know group 16 is after group 15. So their atomic and ionic radii will be smaller than, I'm not going to write. I told because of that initially I have taken it. So atomic and ionic radii of group 15, so group 16 elements will be smaller than corresponding. Try to remember corresponding. Means, see here, corresponding means what? You have nitrogen, you have oxygen. You have phosphorus, you have sulfur. You have arsenic, you have selenium. Means, this will be smaller than this will be smaller than this will be smaller. So, corresponding elements of group 15. And ionic, sorry, same is the case of ionic radius also. And when you go down the group, see, when you go for period, we compare with the other elements of the other group. And when you go down the group, we compare within them. So when you go down the group, their atomic and ionic radii increases due to the addition of extra shells. So let me again tell you that the atomic and ionic radii of group 16 elements are smaller than corresponding group 15 elements. Why? Due to increase in their effective nuclear charge. And when you go down the group, atomic and ionic radii increases due to the addition of extra shells. Done? Very nice. Wonderful. Very good. Now come the ionization enthalpy. So ionization enthalpy This I'm going to write. See, ionization enthalpy also increases from left to right. So ionization enthalpy of group 16 elements should have been more than group 15 elements. But we find that the ionization enthalpy of group 16 elements are lesser than corresponding group 15 elements. Why? Because group 15 elements have stable half-filled electronic configuration. So this I'm going to. Ionization enthalpies of group 16 elements are less than corresponding group 15. Okay? Why? This is because group 15 elements have more stable half-filled. See here, NS2, NP3 electronic configuration. That is important for your exam. Okay, let me put in. I want to finish as much inorganic in this month so that I can start organic. Organic, so many chapters and big chapters. I want to finish. I don't know. Even you cannot finish also by middle of this December. I have to go out. I have some work. Okay, so this is done. Now, then C. Yeah, remove all this one. C. Now, electron gain enthalpy. Mind it, dear, electron gain enthalpy does not depend upon electronic configuration. So it will be less. And how is it there? It is negative. So what you can write now here? That negative electron gain enthalpy value of group 16 elements are more than corresponding group 15 elements. So it is not ionization enthalpy. Huh? So that I'm not writing, I'm telling you the negative electron gain enthalpy value of group 16 elements. Oh, let me write. The negative electron gain enthalpy values of group 16 elements are more than corresponding group 15 elements. Okay. Then what will happen if we go down the group? It will decrease. It decreases from top to bottom of the group due to increase in their sizes. Acha, here I have to write why na? Because of increase, sorry, in their effective nuclear charge. Now I'm going to tell you a very interesting thing. This is there in your book, but it is there in class 11, not in class 12, and it is important for entrance also. Moment you finish, you tell. Finished?
Yes, sir.
See here, just now I will tell that the negative value decreases from top to bottom. But very interestingly, you will find sulfur is below oxygen, but the electron enthalpy value of sulfur is more negative than that of oxygen. At the very beginning only, you have found our theory is not being followed. So I'll tell you the reason. We'll write now. Yeah. However, the first electron gain enthalpy value of sulfur is found to be more negative than that of oxygen. So let us try to understand. It's not that whatever I say, it is the word from the God's mouth. No. You have every right to ask me, sir, why it is like this? Are you saying ulta pulta? See here. What is the meaning of first? See, oxygen has 6 electrons. I have written na? And it is NS2, NP4, so 6. So this is the atom. Now it takes 1 electron. What should you write now here? This is the. So as it's taken 1 electron, what should you put? We put 1 negative charge. Why? Because extra electron means extra negative charge. So from here the energy delta H EG. This is called the EG1. First electron gain. Okay. And this is coming in the as it's given out here, so it's negative. Then it takes 1 more electron and achieve octet. Because of that, you write 2. So after that also it gives us energy. So that is, we'll write now here delta H EG. So we are talking about this one. So we have found how about the first electron enthalpy value of sulfur is found to be more negative than that of that of oxygen. Now let us see. See here. This is oxygen nucleus, and these are the 2 electrons you have. And here you have 6 electrons. See, it is very small. and here you are supposed to add one electron. So you will get what? You need not draw it. What you are going to get? 1, 2, 3, 4, 5, 6, 7. Okay. Now this is for oxygen. This is O minus. Now I go for sulfur. See here, sulfur. Sulfur has one extra shells. So I'll put here 3, 4, 5, 6, 7, and this is the other one. 1, 2, 3, 4, 5, 6. I have to add electron. So it should have a visual display. Simply my word will not help. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. See here. All the electrons are having negative charge. The size of the orbital is small. Want to put one more here. Huge repulsion takes place. Just like this, suppose you are sitting in the back side of the tourist taxi. Okay. Comfortably you are sitting. When that driver puts another one, you develop some uneasiness. But if the vehicle would have been big, if one more person comes, then you do not have so much problem. See, now this electron resists. So you in that case, what happens? The stability of the O minus is less than the oxygen. You see here, this is sulfur and this is S minus. See, in this case, this repulsion is very, very less, almost nil. So in that case, we find this value is, this is more stable than this. So this value is more. Now I have to put one more. Just like that, if the fourth passenger comes inside your backside of the taxi, as you are helpless, you are going. Otherwise, you will go down and start walking. So in that case, you'll find very interestingly here, the second electron gain enthalpy value of oxygen is positive. So I'll now this one I'm going to write down. So you need not draw all this thing. So here I'll write. So we'll write here, due to small size of oxygen atom, a repulsion takes place between valence electron, these are the valence electrons, and incoming electron. Incoming. That is the one which is coming. By which the value decreases. While no such phenomenon, right, repulsion, occurs in larger sulfur atom. We'll write now here. Note. The second electron gain enthalpy of oxygen is positive.
Done, sir.
So this you have to remember. So this is happening because only because of the space, and as the space is less, repulsion. So what is the next one? Electronegativity. So again, it is the same. So same thing. The electronegativity of group 16 elements are more than corresponding group 15 elements. Why? Because of the higher effective nuclear charge. And when you go down the group, the electronegativity decreases due to the increase in their sizes, or you can write addition of extra shells. See, ionization enthalpy, electron gain enthalpy, electronegativity depends on atomic radius. And if you bring three of them together, it interprets the chemical nature of the compound or the element. So what will be the next one? Metallic property. See, when you go down the group, here only within group, we are not discussing another. When you go down the group, ionization enthalpy decreases, means it can lose electron more easily than the upper one. Then their electron gain enthalpy value decreases, become less negative. That is, in that case, they don't have a tendency to take electron from others. That is what? Who doesn't take electron from others? Metals. The electronegativity decreases, means what? They do not have a tendency to put electron towards others. So these are nothing called the metallic property. Okay. So the next is metallic. So what we will find here? Metallic property of these elements increases. Or what I can write? Non-metallic property decreases down the group. Why? Due to decrease. Due to decrease in their ionization enthalpy, negative electron gain, enthalpy and electron. But why does it? Why do they replace electronegativity? But why? Because of increase in their size. Okay, now we'll go for catenation. Yeah. Oxygen shows very little tendency to catenate. Why? Because oxygen form O2 and O3 maximum, not beyond that. Sulfur shows maximum catenation. Catenation decreases from sulfur to polonium because of the increase in their sizes. Okay, EFG. Allotropy. All these elements exist in several allotropic forms. Oxygen has two allotropes, dioxygen O2 and O3. Sulfur has many, so other elements also. For oxygen, both O2 and O3 we are going to study. For sulfur, we are going to study some of the allotrope like rhombic sulfur, monoclinic sulfur, plastic sulfur, all these things are there. So now we'll go to chemical properties. Chemical properties. First will be oxidation. Oxidation states. All these this will be wrong to say that. We'll write here now. Group 16 elements exhibit oxidation states from -2 to +6. We'll try to see how does it show. Okay. So it is NS2 and P4. So this is -2 or +2. When comes the -2 again? That also I told you what is 1 -2. When these elements combine with less electropositive element, then it will be -2. Like water, H2O. Oxygen is more electronegative than hydrogen. So in water, oxidation state of oxygen is -2. In H2S, hydrogen is less electronegative than sulfur. So the oxidation state of the sulfur in H2S is -2. But when sulfur combines with more electronegative elements, say it is chlorine, SCl2. So in that case, oxidation state of sulfur will be +2. Okay. Now, if this pair breaks and moves here, we will have how many unpaired electrons? We have 4. So it is +4. Why not -4? No, because less electronegative element cannot attract other electrons. More electronegative elements can only can elect. So it is the more electronegative elements, then the elements can pull the electron outside. So it will be +4. And if this also breaks, then you will find this will go here. So it will be 1, 2, 3, 4, 5, 6. So this is for +6 oxidation state. So now we have to write something here. Here we will say. So we'll find the stability of higher oxidation state of these elements decreases down the means what is higher stability? +6. Decreases down the group. Why? You know it due to inner peer effect. Then next, the higher oxidation states of these elements. This is a universal truth I'm going to say. States of these elements can be achieved only by strong electronegative elements. Like what? Like oxygen or halogen. Like out of halogen also fluorine, chlorine, bromine, iodine. So the oxidation electronegativity of fluorine is highest. Fluorine and oxygen are almost nearer to each other. So bromine and iodine cannot achieve. So it can be achieved by fluorine and oxygen and some cases chlorine. Okay, now next. Oxygen cannot not cannot, does not show oxidation state beyond +2. Why? Because oxygen does not have d orbital. This is not there. So how oxygen will send this electron to the d orbital to achieve +4 and +6? So oxygen does not show oxidation state beyond +2 due to the absence of d orbital. Hello. Hello. What is reactivity? takes so much of energy to have this board. Okay, now we'll go for reactivity. So now we write down here. Say it is 1. Reactivity with hydrogen. Reactivity with hydrogen. All right. Now, so we write now here. Group 16 elements react with hydrogen to form hydride. Now the question is that why do you call it hydride? Because in class 11th, I think you do not study hydrogen. If any element combines only with hydrogen, these compounds are called hydrides. So definition of hydrides, it is a binary compound of hydrogen. Means hydrogen will be there and other than hydrogen something else. From the hydrides of the type E. What is E? E, so you know, oxygen, sulfur, selenium, tellurium, and so let us know the name. So this one, so you know, we call it water. H2S is called hydrogen sulfide. So you always we write positive on the left and negative on the right. Because of that, I told you, no, they have -2 oxidation state because of. Then H2SC is called hydrogen selenide. H2PE is called hydrogen telluride. And H2PO is called hydrogen polo. You should know the name. Go on to finish your tell. You have been reading quite right from beginning. Sitting from here, I can see whether you have finished or not.
Done, sir.
Yes, good. Okay. So just like the previous group 19, here also we are going to discuss about its stability. No, I told you, no, it is same for every group. So you don't have to break your head. From very beginning, never think negative. Always start everything with yes. So many things are there. Every day we are learning. So here we call it stability. Means what? I'll hit them and see whether their bond breaks or not. If at all the bond breaks, Is it same for all, or for some it is fast and some it is slower? So we write as thermal stability. See, as you go down the group, size of the atom increases. As the size of the atom increases, hydrogen is constant. As the size of the atom increases, the element and the hydrogen bond increases. And that way it becomes more and more fragile. It breaks. So what should we say? We'll say here, thermal stability of group 16 hydrides decreases down the group. But why? As EH bond length increases. Why? Due to increase in the size of central atom. Don't get confused. Central atom E. See, how do you write H2S? This. See here, this is central atom. It increases. So therefore, what I can say? Therefore, thermal stability. Write down here H2O, the most stable, H2S, H2SE, H2T, and H2. But generally, we do not use this one. Why? Because polonium is radioactive. Do you know who has discovered polonium? Hmm? Hello. See, 15, 16 students are there. None of you speak. I'm very depressed with you.
Sir, can you
Whether
repeat
you
the
know
question
or don't
again?
know, you tell. Who had discovered polonium? Hmm? Okay, hint.
Sir, Mary
It was
Curie.
being discovered by, yes, Madam Marie Curie. She has discovered in her research laboratory in Paris, but she is originally from Poland. So yes, because of that, she has named it as polonium. All right. Now, I want to tell you, suppose you heat it. Say I have taken here H, E, I'll write in the center. H, E, H. Okay. This one I heated in the gaseous condition. What will happen? You will get here 2 hydrogen atom and element because it has undergone decomposition. Now, same thing if I have taken in water. You know how it will dissociate if you heat it? Very strange. It will dissociate as 2 minus 2H plus. And we utilize both of them. If I heat it in gaseous state or in liquid condition, no water, no polar solvent, then I get hydrogen. This hydrogen I use it for reduction. Nascent hydrogen are strong reducing agent. And if it's in aqueous solution, if I heat it, it gives me 2H plus. Any substance who gives H plus ion, we call them as acid. Okay? So we are going to utilize both of them. So now I write here reducing capacity. See, who will give you the hydrogen first? This one, this has minimum energy. So this is the strongest reducing agent. I told you we are not going to use this one because it's radioactive, is going to harm us. So what we write now here? Reducing the capacity of group 16 hydrides increases down the group due to decrease in their thermal stability. Means what? What I can write here? Or in decrease in their bond dissociation enthalpy. But why? Because of increase in EH bond. If a substance is longer now, you can break it easily. You can try with your pencil. Take, break it. And when pencil becomes very small, try, you will not be able to break. So what you can write now here? Therefore, reducing capacity is what? I'll write here now. H2O, H2S, 2SC, H2P. So that you do either in liquid condition, pure liquid condition, or in gaseous condition. Okay. But mind it, all of them are in gaseous condition. All of them exist in gas. So what we have learned from there, that water is not at all a reducing agent, because oxygen hydrogen bond, if you heat it very high, it will vaporize, but it will not break. So water is not a reducing. Okay. Now we go for second condition. Acidity. Okay. Acidity. So now in that case, I will lessen my what I simply write here acidity of group 16. Same word by word. And this will be okay. After finishing, once we finish, let me write it. Have you written this portion? Huh? Hello.
Yes, sir.
Yes, sir.
Yes, sir.
Yes, sir.
Okay. Here you will write now. This question is very, very important. They are asked. That why hydrogen telluride is more acidic than H2S. By the by, did I send you the question answers of the chapters? Did I send or I did not send? Hello.
No,
Did
sir.
I send question answers for the chapters that I have taught? Not a single of them. Or you do not know?
So just a PDF.
Sir, just notes, sir.
Oh, question. Okay, I'll send the question answer. You remind me. Any one of you, please call me and remind me on Sunday morning or Saturday morning also. Okay. So we have finished this. Now we will go boiling point and melting. So let me write boiling point only. The boiling point depends upon intermolecular forces of attraction, and intermolecular forces of attraction increases with the sizes. So when you go down the group, sizes increases. So the intermolecular force of attraction also increases, and the boiling point increases. So we write here boiling point of group 16 hydrides increases down the group due to increase in their intermolecular forces attraction, which increases with the size, which increases with the size. However, the water has the smallest size, so its boiling point should be least. But we find, however, water has the highest boiling point among all, as they are closely associated with each other by strong intermolecular forces of attraction. So thus, boiling point. What should I write now here? I'll write it like this. H2S, H2SC, H2TE, and this one I'll write like H2O.
Done, sir.
now we'll go towards the reactivity of oxygen. Group 16 elements combined with oxygen to form oxides of the type EO2 and EO2. What is E here? Oxygen, sulfur, selenium, tellurium, polonium. Make some points, huh? Right. The stability of higher oxidation state thickness group due to the example I have EO sulfur trioxide is very stable, but if I go to tellurium trioxide, E is that they are less. Metal oxides are acidic, and metal oxides are basic. The acidity of the oxides as basic. This one is weakly basic. So please remember this one. Third, the higher oxidation state oxides are more acidic. What does it mean? See here, you have sulfur trioxide acidity. See, this is +6. This is more acidic than sulfur trioxide. This possible information I have to give you for entrance. very big now. You cannot finish.
Sit down.
Okay. Now, see, though I told you that it formed dioxides and trioxide, but they also form monoxides. Well, right now, yeah. One. Monoxide. Except selenium, other form monoxide of the type sulfur monoxide, tellurium monoxide, and polonium monoxide. Second, dioxides. All of them form dioxide. Sulfur dioxide, selenium dioxide, tellurium dioxide, and polonium dioxide. Okay, here. Except sulfur dioxide, which is gaseous. Others are solid. It is because sulfur being small atom form p pi bonds with oxygen and exist in monomeric form. So don't get scared. Monomer means single unit. See here. This is the one. In gaseous condition, everything exists in monomeric form. So it exists in monomeric form, because of that it is gaseous. The others cannot form p pi bond with oxygen and exist in polymeric form. Anyway, all these words are missing in my textbook. Polymeric form and are, don't worry, I'm going to see here. Let us go to selenium. This atom is very large. So this large atom cannot form pi bond with the small oxygen atom. Okay. So in that case, but valency of selenium is 2. Sorry, 4. The oxidation state is 4 plus 4. See now. So this is the one. It can form only single bond. But look, its valency is not satisfied. Huh? So in that case, what is going to happen? See here. They exist in this form. But how to satisfy? See. Is one oxygen atom of one selenium bond bind together. So this way a chain is being formed. So it exists in the polymer. Polymer has large mass, so they exist in solid.
Done, sir.
Okay. So now we'll go to trioxides. All these elements form trioxide. Obviously not oxygen. It is, say it is EO3. That you have sulfur trioxide, selenium trioxide, then tellurium trioxide, polonium trioxide. So we will not take top of this. Here also you'll find sulfur trioxide is gas. Why? Others are solid. Same thing. Here also they form polymeric linkage. So because of that, they exist in solid. Okay. Now I'm going to tell you a very important thing. I told you that higher oxidation state oxides are not stable when you go down the group. I also told you that tellurium TeO3 is not stable. So it wants to come back to the +4 TeO3 oxidation state of tellurium is +6, but it's not stable. It wants to come back to the tellurium dioxide. Tellurium dioxide has +4 oxidation state, so tellurium is found to be more stable in +2 oxidation. Okay, all right. Due to inert pair effect, higher oxidation state oxides of tellurium is not stable. Let me write here stable. What is the stability here? It is more stable than PO2 and is more stable than PO2. So because of that, what you will find, this is +6, this is +4, and this is +4. So they will come from here to here and here to here. So when higher oxidation states come down to lower oxidation states, they take electron from others. Because of that, you will find here that tellurium trioxide is a strong oxidizing agent. So we'll write down here. Huh? Higher oxides of tellurium is oxidizing in nature. Now, so inert pair effect is more at the bottom but less at the top. So what you will find, the sulfur will be more stable in +3, +6 oxidation state than that of +4. So we will find here sulfur trioxide is more stable than sulfur dioxide due to less inert. This is only for entrance exam. Inert pair. Hence, sulfur dioxide is a strong, that we will do also. It is there in the syllabus. Strong reducing. Please remember for your entrance exam. This is there in your book, but this is not there in your book.
Done, sir.
Okay. I will not move further. I just want to taking, but you will be little tired. And the highlights of this we have to discuss little in detail. So I shall meet you on Saturday and followed by Sunday. Welcome. Thank you.
Thank you, sir.
Good night.
Thank you, sir.
Welcome. Welcome.
Thank you, sir.